Hi everyone, Mrs. Greenman here. Today I'm going to talk to you about taking the log of both sides. But before we do that, we're going to start with two warm-up problems. If you'd like, pause the video, try them on your own, and then you can resume and kind of see how I'm going to talk through these problems. For the first problem, we have 8 to the x power equals 10. And I have no idea off the top of my head when you have 8, I don't know what power you raise it to get 10. So what we're going to do is we're going to take this exponential equation and we're going to rewrite it as a log equation. So we have log base 8 of 10 equals x. And remember from the lesson right before this, you learned about the change of base property. So we can say log 10 divided by log of 8 equals x. And you can put that in your calculator and you get that x is approximately 1.107. So if you were to raise 8 to the power of 1.107, you would get 10. So it's always helpful to check your work. Number 2 is a little bit tricky. We have an exponential equation, but there's a lot going on in this equation. So what's really helpful is you always want to remember to isolate the exponential piece. So our goal is going to try to isolate this part of our equation first. So just using some simple algebra skills, you're going to subtract both 6 from both sides, and you'll be left with negative 5 times 3 to the power of x plus 1 equals negative 35. And then you can divide both sides by negative 5, and you get 3 to the power of x plus 1 equals 7. Now you can take this exponential equation and rewrite it as a log equation. So that's going to be log base 3 of 7 equals x plus 1. And our goal is to solve for x. So we can use the change of base formula here. So we have log 7 divided by the log of 3, which is going to be a number that we can get in our calculator. And we want to also subtract 1 because we have x plus 1 and we're trying to solve for x. So we can put all of this in our calculator. Log of 7 divided by 3, hit enter and subtract 1. And you will get that x is equal to 0.771. So as we reviewed from these two warm-up problems, yesterday you learned how to solve exponential equations using the change of base property, okay? And as we reviewed in the two problems above, the way that works is you take your equation that's written in exponential form, your exponential equation, and you rewrite it as a log equation. So this is going to be log base 2 of 5 equals x. And you use your change of base formula, log of 5 divided by log of 2 equals x. You put it in your calculator, and if you round to the nearest hundredths, you're going to get x is equal to 2.322. And again, you can always check. That means 2 raised to the power, so 2 raised to the power of 2.322 is going to give you 5, okay? So today we're going to solve using a different method. And the method that we're going to learn today is we're going to learn how to take the logarithm of both sides. We're going to start off simple, and then we're going to work on some problems that are a little bit more challenging. So if you take a look at this first problem below, we have 2 to the power of x equals 5. So we're not going to use the change of base property, which we worked with in the lesson yesterday. What we're going to do here is we're going to take the log of both sides. So we're going to take the log of the left side of the equation, and we're going to take the log of the right side of the equation. So whatever you do to one side, you're going to do to the other. Now, remember that when we have a log equation, we can use our power property. So this exponent here, this exponent of x, right? Remember the exponent, the rule is the exponent comes in front. The exponent, I like to say, jumps over the log to help you remember. So what you're going to have here is x times the log of 2 equals the log of 5. Now the log of 5 and the log of 2, those are just numerical values, and our goal is to try to solve for x. So x is being multiplied by the log of 2, so we're going to divide both sides by the log of 2. And now we have x equals log of 5 divided by log of 2, and we will get x equals 2.322. So as you can see, in this example, we solved using the change of base property. And for the same exact equation, we solved a different method by taking the log of both sides, but you got the same exact answer, okay? So what we did here in this last example is we took the log of both sides. So we took the log of both sides, We used our power property, the exponent came in front, and then we isolated the variable, which was x. So let's try another example. Let's look at example 2. So we're going to be working today with this new method, which is taking the log of both sides. So here we're going to work with example 2. We have 2 to the power of x plus 1 equals 9. And our goal is to figure out when we add 1 to some number and take 2 and raise it to that power, we get 9. And I can't do that in my head. So what we're going to do is we're going to take the log of both sides. So we're going to say the log of 2 to the power of x plus 1 equals the log of 9. So remember, we're going to see here that this exponent, right, this exponent, using our power rule, the exponent of x plus 1 can come in front, and we can rewrite that as x plus 1. And since it's a binomial here, I'm going to just keep it in parentheses. X plus 1 times the log of 2 is equal to the log of 9. And our goal is to solve for x. So what I'm going to do, x plus 1 is being multiplied by the log of 2. So we're going to divide both sides by the log of 2. Okay, and now we have x plus 1 equals the log of 9 divided by the log of 2, which is just going to be a numerical value. And our goal is to find x, and x is being added to 1. So we're going to subtract 1 from both sides. So x is going to equal log of 9 divided by log of 2 minus 1. And you can put this entire right side of your equation in your calculator. You can do the log of 9 divided by the log of 2, hit enter, and then subtract 1. And if you round to the nearest thousandths, you will get 2.170. Okay, we're going to work through 2 more examples, and these examples are tricky. So let's look at example 3. So if you notice in example 3, our goal is still to solve for x, but we have an x in both positions of our exponent. So we have 3 to the power of 2x and 6 to the power of 1 minus x. And we're looking for the value of x that makes this equation true. So again, you should always check your work. So we're going to use the method that we're working with today, and we're going to take the log of both sides. So we have the log 3 to the power of 2x equals the log of 6 to the power of 1 minus x. Okay, now remember, we're going to start this off the same way. We're going to use our power product, our power property. We're going to take this power and put it in front of the log here. The exponent jumps over our log. So we have 2x, okay, times the log of 3. If you want, put that little multiplication symbol in to help you remember. And then you have 1 minus x, and since it's a binomial, I'm going to put it in parentheses, times the log of 6. Now, in all of the other examples so far, we've only had an x in one place. Here, we have an x on the left side of the equation and an x on the right side of the equation. So when we're asked to solve for x, well, which x? Well, our goal right now is going to be to try to move all of the terms that have an x to one side of the equation and all the terms that don't contain an x to the other side of the equation. The first thing we want to do here is notice that we have on the right side, we have 1 minus x. This binomial is being multiplied to log of 6. So what we're going to first have to do is we're going to have to distribute to the log of 6. So this 1 is going to be multiplied by the log of 6 and the negative x. So what that's going to look like is 2x times the log of 3 equals 1 times the log of 6. So I'm going to write it out just so you can see what I'm doing. But 1 times log of 6 is log of 6 minus x times log of 6. Okay, so we have 2 terms here with an x. So we have 2x log 3 and we have x log 6. This term here, 1 log 6, has no variable, no x value, so that's going to stay put. I'm going to move all the terms that contain an x to the left side of the equation. So I'm going to move this term here to the left side by adding x log 6 to both sides. Okay, so we have 2x times log 3 plus x times log 6. If it helps you, put that little multiplication here if you want, equals, and 1 times log of 6 is just log 6. Okay, log of 6 is a number, okay? We have now moved all of the x's to the left side of the equation, which is great. We have an x here and an x here. But because we have the x twice, we can rewrite it by factoring out the x. So the reverse distributive property is factoring. So I'm going to take this x here and this x here, and I'm going to rewrite the left side of the equation in an equivalent way. So I'm going to factor out the x. It's going to be x and then 2 times log of 3 plus log of 6 equals log of 6. Okay, so now what we've done basically is that we've taken the left side here and rewritten it in an equivalent way by factoring out the x. So now if you look in the parentheses, you have 2 log 3 plus log of 6. That's just a number, okay? So what we're going to do, we have x, which is being multiplied by whatever this value is. So to undo multiplication, I'm going to divide. So I'm going to divide both sides of my equation by 2 log 3 plus log of 6 divided by 2 log 3 plus log of 6, okay? So this is going to cancel and just give me 1. So I get x equals, now I can go right to my calculator. I can take the log of 6 divided by 2 log 3 plus log of 6. If you put it all in your calculator, it's helpful to put parentheses around what's in the numerator and parentheses around what's in the denominator. Just be careful. And when you round to the nearest thousandths, you get x equals 0.449. So far this has been the trickiest example, so you just want to be careful. If you want to rewatch this problem again, work through it on your own just to be careful. The key is that we had a variable on both sides, so here are the steps that we're going to take. So let's write this down. When x, or whatever your variable is on both sides. Okay, so here's what we did. Step 1, the first thing we did was we took the log, so take the log of both sides. Okay? So that's the first thing that we did. Then we used the power property. Okay? After that, we distributed the logs, right? Remember over here, we took this log of 6 and distributed it to the 1 minus x, that binomial. So we distribute the logs, and sometimes you might have to do that more than once depending on the setup. Okay, the next thing you want to do is move all terms with x's on one side of the equation and all of the other terms to the other side, okay? Then we factored out the x and then isolate and solve for x. Okay, so here are the steps in words with what we've done for example 3, if it helps you to have it written down. Okay, we're going to work through one more example together, and then you guys are going to practice. This example is similar to example 3, but is a little bit tricky as well. So if you take a look at example 3, we have 5 to the power of 2x minus 1 equals 20 to the power of x plus 3. So immediately when I see this, I see that I have a variable on both sides. So it's going to be a little bit more complicated. So remember, our first step, we said what we're going to do is we're going to take the log of both sides and then use the power property. So I'm going to take the log of both sides. So I'm going to have the log 5 to the power of 2x minus 1 equals the log of 20 to the power of x plus 3. So using my power property, I'm going to take this exponent here and this exponent here, and it's going to come in front. So I have 2x minus 1, and since it's a binomial, I'm going to put in parentheses times the log of 5 equals x plus 3, another binomial, times the log of 20. So what I'm going to need to do is I'm going to distribute my log. So I'm going to take that log of 5 and I'm going to distribute to both of these terms, and the log of 20, and I'm going to distribute to both of those terms. So what we have here is 2x times the log of 5 minus 1 times the log of 5 is minus log of 5 equals x times log of 20 plus 3 times the log of 20. So again, our goal is to solve for x, but we have an x over here, we have an x over here. So we want to move all of our terms with x to one side of the equation and all of the terms that don't contain x to the other side. So what I'm going to do is I'm going to move all the terms with an x to the left and all of the terms that don't have an x to the right-hand side. So I'm going to subtract x log 20, and I'm going to move that to the left side of my equation. Okay, so I have 2x log 5 minus x log 20 minus log 5 equals 3 log 20. And now this term, minus log 5, does not have an x, so I'm going to add that to the other side. And what I'm going to be left with is 2x log 5 minus x log 20 equals 3 log 20 plus log 5. So it looks really complicated, but 3 log 20 and log of 5, that's just a number, and our calculator is going to be able to tell us what that is. If you look at the left side now, we have all the x's on the left side of our equation. We have an x with this term and an x with this term. So we want to rewrite this in an equivalent way. So instead of having the x written twice, we're going to factor out the x, and we're left with 2 log 5 minus log 20 equals 3 log 20 plus log 5. And our goal was to solve for x, so x is being multiplied by 2 log 5 minus log 20. So I'm going to divide that value on both sides. So I'm going to divide 2 log 5 minus log 20 on the left side and on the right side of my equation. So I have x equals, and now what I'm going to do when I use my calculator, I'm going to put parentheses around what's in the numerator, and then I'm going to hit the division symbol, and then I'm going to put parentheses around what's in the denominator, so my calculator follows the order of operations correctly. So if you do that, you put parentheses, you do 3 log 20 plus log of 5, and then open up parentheses for the denominator as well, just so your calculator keeps everything straight, minus log of 20. And what you should get is that x equals 47.488 when you round to the nearest thousandths. And it's always helpful to go back and check. That means that at the beginning of our problem, that's what x was equal to make the left-hand side equal to the right-hand side of our equation. What you will find now is you will find practice problems. You can work on these and then see your teacher if you have any questions.